Hey guys, in this video we're going to be covering 5.8.3. Our mastery learning objective is I can calculate the probability of compound events by determining whether they are independent events or dependent. So hopefully you remember last video we dealt with independent. Just as a little refresher, is independent, with a little arrow here. This is when we've seen those words and the word replaces, or the word put back, right? Put back. And then when we solve for these, we also multiply. Alright, so that was independent. Today, what we're going to be doing is dependent events. So I see already there's a little typo on our notes here. Go ahead and scratch off the IN. Should say dependent. So these are dependent events. So dependent are kind of the opposite. Dependent actually does affect one event. So one event does affect the outcomes of the other. So when you do find the probability of something, it affects what's coming next. Some of the keywords for this one is words like without replacing it. So maybe you take out a marble and then you don't put it back. Or you see the word keeps, so like you keep a marble or whatever scenario it may be. You might also see something that says doesn't put back. So these are all kind of hints for you to know that this is a dependent event, and then it's going to kind of change our outcome a little bit. So operation though is still going to be multiplication. Multiplication. Alright, so for this first activity, all we're actually doing for these first four examples is just determining if it is independent or dependent. So let's read some of these. So the first thing is you flip a coin and then roll a fair six-sided dice. The coin lands heads up and the die shows a 1. So the first thing is, do we see any of these keywords? So first one I seen was the word and means independent. They are independent of each other. So anytime you see and, it is independent. Right, two things happening at once, but whatever you flip the coin, it's not affecting what you roll on the dice, right? They're separate things happening. Number 2, a bag contains 8 red marbles and 4 blue marbles. Okay, so that's nice to know. So we have 8 red marbles, 4 blue marbles. I do see that word and then it says you randomly pick a marble and then pick a second marble though without returning the marble to the bag. So that's kind of big. So you take the second one without putting the first one back. So without returning here is going to change our outcome, because the second time we pick, we have one less marble to choose from. So this is why this event is going to be dependent, because whatever I pick first, that's definitely going to affect what I get second, because I'm not putting that first marble back in my bag of marbles. Alright, number 3, a box of chocolates contains 5 milk chocolates, 5 dark chocolates, and 5 white chocolates. You randomly select and eat 3 chocolates. So we're picking 3. The first piece is milk chocolate, the second is in dark chocolate, and the third is in white chocolate. So, well, the thing is it doesn't really say I'm replacing it or I'm not replacing it, but think of what is actually happening. You are eating 3 chocolates. I'm just telling you that you are eating it. So obviously you're not going to eat it and then put it back because you ate it, right? So this is why it's going to be dependent, because once I pick that first chocolate, it's going to make my chocolate selection 1 less every time I pick the second or the third one. So the reason why it is dependent, if you want to put on the side, is if you eat them, you don't put them back. Right? So you're eating a chocolate. So one less chocolate every time you pick one. So that is why it's dependent. It's going to depend on whatever you got first. Number 4, it says a cooler contains 10 bottles of sports drinks, 4 lemon lime flavors, 3 orange flavored, and 3 fruit punch flavored. You randomly grab a bottle, return it to the cooler, and then grab a different bottle. The first time you get a lemon lime drink, and the second time you get a fruit punch drink. So this is important. We are picking something randomly, but we return it back to the cooler. So if you're putting it back, you have a chance of selecting that again. So it doesn't really matter what you pick first, because you can get that second or third or however many times you are picking something. So you really have to be able to read closely. That is not spelled right. E-A-P-E-N. I don't know what I was doing there. D-E-N-T. There we go. This is a really long word. Anyway, so again, we're putting it back in the cooler so it is able to be selected again, and then it is an independent event. Alright, so let's kind of look at these. So example number 1, there is 1 yellow marble, 2 green marbles, 4 red marbles, and 5 blue marbles in a bag. Once a marble is drawn, it is replaced. So that is important. So we're putting it back. So right away we know it's going to be independent. Find the probability of each outcome. The first thing is I want to figure out what the total is. If I have 1, 2, 4, and 5, our total here, 1 plus 2 plus 4 plus 5 is going to give me 12. Alright, so if we're putting something back, let's try to find the probability of this. So P, probability of picking a blue, then a red marble. Another thing I would like you to remember is that the word then is the same as the word and. Okay, so it's just going to mean you multiply. Okay, so what is the probability of picking a blue one? Well, how many blues did we have? We had 5 blue marbles. So 5 blue over how many total marbles did we have? That was 12 total. Then means multiply. And how many red marbles? So red marbles was 4. And now, when I think of the total, because it told us that we replaced it, I picked the blue one and then I'm going to put it back. So I'm still going to have 12 marbles to choose from when I pick the second time. So when I'm multiplying these and get a simplified answer, I am going to get 5 over 36. So that is the probability of picking a blue and then a red. What is the probability of picking 2 green marbles in a row? So the first time I pick a blue marble, what is the chances of that? Well, that's going to be 2 green over our 12 total. Hopefully I get a green one. I'm going to pick it up and then I'm going to put it back. So it doesn't change my outcome of how many greens there are. It's still going to be 2 green. And it's still going to be 12 total because I haven't taken anything out. So these again are all independent events. So when I'm multiplying these, I get a simplified answer of 1 over 36. If you need to write this for yourself just so that you know what this means, probability of 2 marbles in a row, sometimes kids like to write this out and say picking a green and then another green, right? It's kind of what we did. We picked one out and then we want to pick another one. All right, so last example here on this question is the probability of a yellow and then a blue marble. So looking up at the top, how many yellows did we have? So we had 1 yellow, still over our 12 total. Then means multiply, right? So we could have had that and then there, and then here. still all means multiply. Our blue marble, how many blues did we have? We had 5 blue. Again, still over our 12 total. When we multiply these out, we get 5 out of 144, which is a pretty low chance of picking a yellow and then a blue. Alright, last example here. So these were all independent, and maybe you can guess that example number 2 is going to be dependent. So if there is 1 yellow marble, 2 green marbles, 4 red marbles, and 5 blue marbles in a bag, once a marble is drawn, it is not replaced. So I'm picking one and then I'm not putting it back. To find the probability of each outcome. So our total stays the same. We still have 12 total marbles, but when I pick one, I'm not going to put it back. So follow with me. If I have probability of a red, then a blue marble. Kind of want to draw something out for you guys, so hopefully it'll make sense for you as to why we have to take one out. So I'm going to kind of draw my marbles out. So I have 1 yellow, and then how many greens do I have? I have 2 greens, and then I have 4 red, so these are my marbles, and then I have 5 blue. Alright, so these are all my marbles. So when I want you to think of this, what is the probability of picking a red one? So I take a red one. How many reds do I have total to pick from? I have 4, right? But I'm only going to take one of them. So if I take one, I had 4 red. Out of how many could I pick from? 12 total. The word then is the same as and, so I'm going to multiply. Then I want to pick a blue marble. So how many blues can I pick from? Well, I have these 5, right? So I have 5 blue, but out of how many did I get to choose from? Well, the fact that I already took this red one out, I don't have 12 anymore to pick from. I have 1 less than that. So that's why this is only going to be out of 11, because it told me I'm not replacing it. I take one out and then I remove it. You know, it's not included in the second time I pick. So that's why this is 1 less right here, because I took that first marble out. Okay, so that's the biggest difference when you're dealing with dependent events. When I multiply this, still the same, I get 5 over 33. Okay, I'm not going to draw out those marbles again. Hopefully that was enough for you guys to understand why that number went down by 1. All right, looking at the next one. What is the probability of picking 2 marbles in a row? So what does this mean? This means the probability of blue and then another blue. All right, so when we first pick a blue, how many do we have? We have 5 blue over our 12 total. And then the word then means multiply. And now how many blues are left? So now, kind of tricky here, because if I pick a blue one in the first time, how many do I have the second time? I only have 4 to pick from now because I took one out. And I'm not replacing it, and that also means I have to subtract 1 from the bottom because I took that first marble out. So if it's the same color, right, blue and blue, I took a blue out and then I took another one. You have to remember to take one out of the numerator as well. So multiplying these out, I get an answer of 5 over 33. Next example is the probability of a green and then a red. So what is the probability of green? Well, how many greens did I have? I had 2 green, and I had 12 total. Then means multiply. All right, this also multiply. This one's going to be multiply. And then what is my probability of red? So red, I have 4 marbles, 4 red ones, and then I did not replace it, so when I pick the second time, I only have 11 total. So this is going to be 2 out of 33 when I multiply those out. Last one here is what is the probability of a blue? So 5 blue and then 2 green in a row. So I have to have the probability of a blue. So 5 blue. This is going to be out of 12 total. The word then means multiply. What's the probability of green? 2 green. But I have 1 less to pick from, so that's only going to be out of 11 total. Multiply, and then I want another green one. So I have to remember that I have to take 1 out of my green selections because I already picked 1. So I only have 1 left to pick from. And then I have to take out another marble because I took out that second marble. So when I multiply these all out, I get a final probability of 1 over 130. Okay, that brings us to the end of this video. Go ahead and work on 5.8.3. Good luck.